With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, the question is a particle start moving in a straight line from rest with constant acceleration until it reaches a velocity v. The distance traveled by it until this point is x. Then it covers a further distance x at a constant velocity. Finally, it slows down to rest at a constant rate such that it covers distance 2x. The total time for which the particle move is t, then tv upon x is equal to. So according to this question, if a particle start from rest, so we take here the initial velocity is equal to 0 at time t equal to 0, then it cover a distance x. Initially it cover a distance x and the time is t equal to t1 and the velocity at this point is v. So if we write here the velocity, that is from equation of first motion, v is equal to u plus at. V is equal to u is 0, initial velocity is 0 plus a into t1. That means the initial velocity is at1. This is equation 1, and the distance s is equal to ut plus half a t square. So the distance here is x, u is 0, half a into t1 square. This is the equation 2. So if this is equation 2, now further it cover a distance x at constant velocity. So we write here that the further it cover a distance x with constant velocity v, and here time is t2. So if we write time t2, t2 is equal to distance upon speed x upon v. This is equation 3. Now, according to the question, it slow down to rest at constant rate such that it cover a distance 2x. Now, it cover distance 2x and final velocity will become 0 and time taken is equal to t3. And here the time interval is t2. So we write here time is t2 plus t1, and here total time t1 plus t2 plus t3, that is given according to the question, that is capital T. Now, initially the acceleration is a. Now, if the velocity decreasing and cover distance 2x, so the retardation is a1. Now, if we have to calculate the value of a1, we apply here that the equation of motion v is equal to u plus at. Final velocity is 0, u is equal to v, and v is equal to at1 minus a1 into t3. So we write here that the value of a1 t3 is equal to a into t1. This is equation 4. Now we have to write here the total time is capital T and the distance traveled in the last time, that is 2x, is equal to s is equal to ut, u is v into t3 minus half a1 into t3 square. So from the value of v is 81, so we write here 2 x is equal to half a into t1 square is equal to v is a t1 into t3. T3 from equation 1 is written as a t1 by a1. Now minus half, we write here a1 into t3 square. T3 square is a square into t1 square upon a1 square. So if we calculate here that the value is 2 cancelled, a t1 square on the right side, we write here a square into t1 square upon a1 minus 1 by 2 here. This will be equal to a square into t1 square upon a1. So a t1 square is equal to, this will be a square by a1 is common. This is equal to t1 square by 2. So we write here the value of A1 is equal to A cancelled, that is T1 square and A cancel. So we write here 1 is equal to A upon A1 into 2. So from here A1 is equal to A by 2. Now the value of the retardation is the half of the acceleration. So according to the question, the total time equal to the T is equal to T1 plus T2 plus T3. This is equation 4. So if we place the value of T1 is equal to 2x upon A square root from here. So we write here that T1 is equal to square root of 2x upon A. T2 is equal to, we write here x upon v. So we write here T2 is x upon v is equal to AT1. Now we place the value of T1, that is x upon A. 1 upon T1 is equal to square root of A upon 2x. So this will be equal to, if we place in a square, that is root of x square A upon A square into 2x. So the value of the T2 will be equal to square root of x upon 2a. So this is the value of T1. We write it equation 5. This is equation 6. Now we have to find the value of T3. So the value of the T3 from equation 4, T3 is equal to the A upon A1. A1 is A by 2 into T1. T1 is equal to square root of 2x upon A. So A cancelled. This is equal to 2 into root 2x by A. So if we place shift 2 in a square root, that is 4 to the 8x by A. This is equation 7. Now put the value of T1, T2 and T3 in equation 4. This will become that the capital T is equal to T1. T1 is square root of 2x upon A. T2, the value of T2 we solve here, that it is square root of x upon 2a. Square root of x upon 2a plus T3 is equal to root of 8x upon A. So T is equal to, we take here comma, square root of x upon A. In bracket it is equal to root 2 plus 1 upon root 2 plus root 8 is equal to 2 root 2. So we solve in the next line that T is equal to square root of x upon A. LCM is root 2. Root 2 into root 2, 2 plus 1. 2 2s are 4. So we write here that capital T is equal to square root of, this is root 2 shift in here, x upon 2a into 2 plus 1, 3 plus 4, 7. This is equal to 7. We have to find here the value of TV upon x. So TV upon x and v is equal to 81. So the value we solve here, that this is in bracket root, it is 7, not root 7. So in the next line, capital T is equal to, v is equal to, in terms of 81 we have to place, this is root x upon 2a, and the value of root x upon 2a, x upon 2a is equal to T2. So we write here this is equal to T2, root x upon t is T2 into 7. So in the next line we write here that the value of capital T, T2 is equal to x upon v into 7. In the next line, TV upon X is equal to 7. So the final answer of this question is TV upon X is equal to 7. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.